Oh, so your y-intercept here was -6. And it still should have gone up from left to right. And they still chose 0, 6, and 3. I don't know why they went out of order, but better? Then number 9. Oh, for this one, so we did do y equals -5x plus 20. So that one is the same one. And then 15. This one was a little more difficult, actually. 4x minus 7y equals 2. Does anybody need to see that one? Okay. So for this one, we have an original equation that looks like this. Y equals 4x minus 2 over 7. They want this in standard form. So we need to get x and y on the same side. Before you do that, though, you need to get rid of that 7. All right? Because remember, even if you don't see it, this guy is grouped. Okay? And so we need to get rid of that 7 first. And we're going to do that by multiplying both sides by 7. So we're going to multiply the left and the right by that 7. So now we have 7y equals, and on this side here, these just cancel. And so it equals just the 4x minus 2. All right. And so then I'm going to move my x over. Remember, I want the x and y on the same side. So I'm going to move 4x over. And I get -4x plus 7y equals -2. Remember when we talked about standard form, I said they want integers. And specifically, they will want the x to be positive. All right? So when you see this, especially on like a standardized test, they will take this negative out. And so I'm going to show you how to do that because that's the standard form here, is to make sure your x is not negative. And so if your x is negative, you really just have to divide everything by -1. So basically you change the sign of everything. So this -4x becomes positive 4x. This positive 7y becomes -7y. And this -2 becomes positive 2. And this is what your standard form would look like. They want integers, and they specifically, so meaning no fractions, and they specifically want your x to be positive. Your leading one, which is your x, will be positive. All right? All right, the first thing we do in this section is we define slope. The word slope probably reminds you of a hill if anyone has ever been skiing, right? They will define the slopes. And actually the slopes for skiing, the magnitude of the slope as far as whether you are in one type of slope or another, and they give you kind of parameters. If you're, like the bunny slope, that's the person that's never done it before, right? That slope is going to be much slighter than maybe like a diamond, right? Which is where if you have a much higher slope, it's going to actually be a steeper slope. And so the word slope kind of reminds you probably of skiing because that's where you hear that term a lot. And it is based off of the mathematical slope, which is what we're going to talk about. The steeper the slope, the faster you go. All right. So it basically describes how steep or what the incline is of what you're looking at. And since we're talking about linear equations, specifically, we're going to be talking about the slope of the lines. So the slope of a line, which is referred to by the variable m, okay? And so when we start getting into our types of lines, we're going to use this variable m to define our slope. It is the ratio. Ratio means we're comparing two numbers between the rise. The rise means how much it changes up and down, to the run. That's the horizontal change. So we always compare the rise, how much it changes up and down, to the run, how much it changes left and right. All right. And so if you look at the example there, they have this particular line here. And all they've done is they have picked 2 points. All right. They've picked point A and point B. Point A has 3, 1 as its coordinates. Point B, 5, 4 as its coordinates. And so they've said, well, how much has it gone up? Well, this particular line went up 3 units compared to how much did it go over? It went over 2 units. All right, 2 units. So this particular slope would be 3 over 2. You put the rise on top, the run on bottom. So if you look at your handout, that's the very first thing at the top of your handout is rise over run. How much has it changed going up and down compared to how much has it changed going left and right? That is the steepness of your particular line. So the first way you can figure out the slope is exactly what we did there. just counting. So if you have an actual image, like a graph of the line, if you want to figure out the slope, you can literally count, right? You can say, okay, I start at this point. How much did I go up? How much did I go over? Okay. Now, you want to keep a couple things in mind when you're doing this, is that, am I moving in a positive direction or a negative direction? Okay. And so when you're thinking about if I'm going up or down or left or right, you have to think about what does that mean for this particular number. If I'm going up, that's going to be positive. If I'm going down, it's going to be negative. If I'm going right, it's going to be positive. If I'm going left, it's going to be negative, right? And so you have to think about that as well when you're counting and using this particular method for finding slope. All right? So then how do we write slope? Slope will always be written as a fraction in lowest form. So you're not going to give me a slope in a decimal, okay? You're going to leave it as a fraction. You're not going to do it as a mixed number, okay? You're going to leave it as a fraction, but you are going to reduce it if possible. So you want to put it as a fraction in simplest form, so in the lowest term possible. The reason you don't want to do it as a decimal is because we are talking, now sometimes you'll see in mathematics decimals and it's just compared to 1. You basically put it in a unit rate when you put it as a decimal. But it doesn't mean as much when you're doing just graphing lines. If you leave it as a fraction, the numerator represents how much you're going up and down, and the denominator represents how much you're going left and right. So it gives you a visual image of how it's changing. All right, so you want to leave it as a fraction. So the first example here says, find the slope of this particular line. Find the slope of this particular line. So when you're doing this, you're going to pick 2 points, and then you're going to count when you have something like this, all right? Now, when you pick the 2 points, let me point out a few things here. I'm not going to pick maybe this guy right here. Why wouldn't I pick him? He's not exactly on a crosshairs. You know what I mean by crosshairs, right? He's in the middle of 2 whole numbers. And so I'm going to have to estimate what point this is. So I don't want to use a point that I need to estimate. I want to use a point that's very obviously on 2 that are crossing here. And so I'm probably going to use this one right here and maybe this one right here. So if I were going to do this particular one, I'm going to use 2 that I can very easily see. So like this right here is directly on a cross. This right here is directly on a cross. And so that's going to help me pay attention to what numbers I'm talking about. All right. So once I do that, you can find the coordinates if you want to. That's fine. So this guy is what? -1, 3 looks like. And this guy is 1, 2. Right. So you can find the coordinates. But really, you want to just count and see what's happening here. So if I start at this far left one, how do I have to move to get to the right one? Well, the first thing I need to do is I need to go down, right? Because when I'm talking about up and down first, all right? I go down. So what number represents going down by 1? -1. So my numerator for my slope here is going to be -1. Now that I have walked down 1, right? I've gone down 1. What do I need to do to get over here? How many units am I moving? 2. Am I moving in the positive direction or the negative direction? Positive direction. So that movement is going to be +2, right? I have a -1 over a +2. My slope is -1/2. You'll notice that I put the negative in front, okay? Because even if I had started at the right point and gone to the left point, it would be the same. If I started at this right point, I would have gone up 1, right? Which would have been +1. And then I would have gone left 2, which would have been -2. +1 over -2, -1 over +2 equals -1/2. Remember, a positive divided by a negative is a negative. So my slope here is -1/2. So go ahead and try those 3 lines. Find your slope of those 3 lines. On page 239, they actually give you a slope formula. So if you're given a graph, you can literally just walk from one point to the next and figure out what the slope is. But sometimes you will just be given points, 2 points without a graph, okay? And there's actually a formula to figure out what it is. The formula is y2 minus y1 over x2 minus x1. So you're going to have 2 points, x, y, x, y. So you're going to have 2 x's and 2 y's, all right? Your numerator, remember, is how much you move up and down. So your numerator is going to be subtracting your y's. Your denominator is going to be subtracting your x's, all right? So this is the formula when you do not have a graph, when you just have 2 points. Subtract your y's over subtracting your x's. Subtract your y's over subtracting your x's. So let's say you've been given these 2 points, all right? 2, -3, 4, 1, all right? 2, -3, 4, 1. So I have these 2 points, all right? And I need to subtract my y's and subtract my x's. So the first thing I typically do here is I label them, all right? If this is my first group, then I'm going to say this is my first x and this is my first y. And then if this is my second group, I'm going to say this is my second x and this is my second y. All right? My groups represent. And I'm going to label it a different way, and we're going to see that it works whichever way as long as you keep them in the same order. So my formula is y2. Well, in this case, my y2 is 1. My y1 is -3. You'll notice I put that in parentheses because I don't want to mess up my positives and negatives here, okay? In the denominator, I subtract my x's. My x2, that is 4. My x1 is 2. Just plugging it in. Subtract my y's, subtract my x's, okay? Now, 1 minus a -3, remember a subtraction is adding the opposite. So in the numerator position, I have 1 plus 3, which gives me 4. In the denominator, I have 4 minus 2, which gives me 2. I want this in simplest form. What's the simplest form of 4 over 2? Yeah, it's just 2. That is my slope, okay? That is my slope. Now, what would have happened if I had labeled them differently, all right? Let's say I labeled them differently. So let's say I labeled this group as x1, y1, and I labeled this group as my second group, x2, y2, all right? So let's do it that way. I'm going to say -3, y2, minus y1. I'm going to do it in a different color here, which is 1. x2, that's 2, minus x1, that is 4. All right? Now, when I do this particular one, -3 minus 1 is -4. 2 minus 4 is -2. What is -4 divided by -2? It's also +2. So here's the thing. It does not matter which group is your first group and which group is your second group. What matters is that you keep it in the same order, okay? What I mean by that is if you start with this group in the numerator, like you start with -3, then in the denominator, you must start with +2. This group has to be together, whether it's second, -3, 2, or whether it's first, -3, 2, okay? If you flip-flop these, then you will get the wrong slope, all right? But as long as -3 and +2 are right over each other in your equation, and -3 and +2 are right over each other in your equation, and then 1 and 4 are right over each other, and 1 and 4 are right over each other, then you're going to be fine, okay? But it doesn't matter which one you start with as long as you keep them in the same order when you go to the denominator. All right, so one of these groups has to be your first group. One of these groups has to be your second group. Any questions on that one? All right, there's a reminder in your book, exactly what I just said. Use x values in the denominator in the same order that you used your y values in the numerator. Okay, so whatever order you did in the numerator, you have to do that same order in the denominator. All right, let's look at your handout. Find the slope between the 2 points. So go ahead and do these 2 problems. Find the slope between the 2 points. They've given you an xy and an xy, 2 of them. Let's go ahead and use your slope equation now to find the slope between these 2 points. Look, they actually give you some keys to finding the slope. When given the graph, determine the rise and run from point to point. When you're given 2 points, you want to label them 1 group, 2 group, whichever label you want there. Then use your formula. Subtract your y's over subtract your x's. So depending on what you've been given, you may do it 2 different ways, okay? So a couple things here. If it'll let me move it. There we go. Couple special cases that I want to point out here. Couple special cases. You have the horizontal lines and vertical lines, which we talked about yesterday when we graphed y equals a number and x equals a number. What you'll find with these is if I have a horizontal line, remember my y's are over each other. Well, my y's here are both 4. So I'm going to get 4 minus 4 on top, which gives me a 0 on top. Over, it really doesn't matter what number's down here. But in this case, I have 7 minus 2, which is 5. 0 divided by anything is 0. So a horizontal line is always going to have a 0 slope. Always. Let's look at the vertical line. My vertical line, well, my numerators, 4 minus a negative 2, 6. But look at my denominators, 3 and 3. 3 minus 3 is 0. I cannot divide by 0. So anytime you have a 0 on bottom, your answer is undefined. A vertical line will always have an undefined slope. Always. Okay? So horizontal lines will have a 0 slope. Vertical lines will have a undefined slope. That will be your answer for those. And so that a little bit, the slope of a horizontal line is 0. The slope of a vertical line is undefined. That is on your handout. Bottom left. The slope of a horizontal line is 0. The slope of a vertical line is undefined. It says graph the line going through the point -1 with a slope of -1/3. Graph the line. So if I'm graphing a line, I need 2 points, right? Well, they've given me 1 point, so I'm going to go ahead and graph that 1 point. -1, +2. So I'm going to go -1 to +2. This is where this point is, -1, 2, right? And then it gave me the slope, -1/3. Now remember, it doesn't matter which one is negative. So this could be -1/3, or it could be +1 over -3. That's the same thing, okay? So let's move based on this first one. My numerator represents my up and down movement, right? Up and down movement. So if I start at this point, what's the first thing I'm going to do to move? Well, I'm going to go down 1 unit, okay? So I'm going to go down 1 unit right here, okay? And then my bottom movement represents left and right, okay? +3. Which direction am I going to move to go +3? Right 3. So I'm going to say 1, 2, 3. So my next dot for this particular line, my next point should be right here, okay? Now let's say I had done it the other way. This movement right here, up and down. So how am I going to move if it's +1? Up 1. So from my same point here, I'm going to go up 1, right? This is -3. This is my left and right movement. How am I going to move here? left 3. So I'm going to go 1, 2, 3, left 3. I'm going to do my other point here. You will notice that if I were now to connect these dots, because that's how you do it when you're graphing, right? Then I would have those 3 points on the same line. It did not matter which one I did. Just the fact that I went one direction or the other, they were the same exact slope, so they ended up on the same line, okay? So that's how you graph if you're given some point and the slope. You start at that point, and then you just walk it. Walk it up and down, walk it left and right to get to your next point, okay? If you have a whole number, so let's say on our example, we had -3. Remember, that was one of our slopes. -3 is -3 over 1. So I would go down 3 and right 1, or up 3 and left 1, okay? So if you have a whole number, it's just over 1. Just over 1. All right, so let's practice some graphing. Practice some graphing here. And this is just your reminder at the bottom left. Up and right are positive, down and left are negative. So on your it wants you to start at the origin's in the middle, with a slope of -3. And then the second line, it wants you to start at 0, 4 with a slope of -3/4. So graph those two lines. They're telling you where to start and how to move. Where to start and how to move. Point and slope. It's at the bottom right of the front page. Bottom right of your front page. On this hand, positive slope should go up, negative slope should go down. Then you have your horizontal and vertical. All right, that's at the bottom of that page. Positive, negative, 0, and undefined.